Hi, in this video I'm going to talk about symmetric and asymmetric encryption. We'll see cryptographic terms, symmetric encryption and its pros and cons, then asymmetric encryption and its pros and cons as well. So let us first understand cryptographic terms. A cipher is a method of encoding a message to keep it private. It involves turning the message into a secret code called ciphertext and decoding it back into the original message using specific rules. There are various types of cipher and they are used to secure messages in various contexts, such as on computers or when storing sensitive information. Secret key. The secret key is a piece of information that is used in conjunction with a cipher to encrypt and decrypt a message. It's a critical part of the encryption process and is used to scramble and unscramble the message in a way that is difficult for anyone who does not have the key to reverse. So don't worry, we are just understanding the explanations. We'll also have an example to see what everything actually is. Plaintext. A plaintext refers to the original unencrypted message or data. It is called plaintext because it is in a readable unencrypted form that can be easily understood by a person. Ciphertext. Ciphertext is the encrypted form of a message. It's the result of applying a cipher or an encryption algorithm to a plaintext message. Ciphertext looks like a random string of characters and is difficult to understand without the secret key that was used to encrypt it. Encryption. It's the process of converting a plaintext message into a ciphertext using a cipher and a secret key. It's used to secure the confidentiality of a message and protect it from being intercepted and read by unauthorized parties. Decryption. Decryption is the process of converting ciphertext back into the original plaintext message using a cipher and secret key. It's the reverse process of encryption and it is used to reveal the original message that was encrypted. So let us understand symmetric encryption. Symmetric encryption is a type of encryption that uses the same secret key for both encryption and decryption process. For example, we want a ciphertext, which is a text that is unreadable for other parties, and we first need to encrypt it with a secret key using encryption process. And here is our plaintext, which is a readable text for anybody. Then we want to decrypt this message as the other party because we want to be able to understand this ciphertext, and to be able to do that we need to decrypt it, and we should use the same secret key in both encryption and decryption processes. Let us give an example through Caesar cipher so that we can understand every process one by one. The Caesar cipher, also known as the shift cipher, is a simple substitution cipher that replaces each letter in the plaintext with a letter a fixed number of positions down the alphabet. So here for A we use D, for example, if the secret key is 3, for B we use E, and for C we use F. So in this regard, let us understand everything by giving an example. Here we have Alice and Bob, and they are trying to send a message to each other using the secret key 3 and the cipher, the Caesar cipher. In this regard, our secret key is 3, which means you need to shift letters positions by 3. And our cipher, our algorithm to implement this secret key is Caesar cipher. And plaintext is basically hello Bob, which is something meaningful. And ciphertext should be unreadable for the other parties. And when we encrypt and decrypt data, or for example, when we decrypt this core EUD, we get the decryption process. And by doing this, we get the hello Bob message again. And of course, to encrypt the message, to make it unreadable for the other parties, we need to convert it from hello Bob to core EUD using secret key 3 and the cipher Caesar cipher. So that's very important to understand that Caesar cipher is a very weak encryption algorithm, can be easily broken by some professionals or even some people. It was primarily used by Julius Caesar to communicate with his generals, and it's not recommended for use in modern cryptography. So what are the pros of symmetric encryption? Symmetric encryption is a type of encryption that uses the same secret key for both the encryption and decryption process. We don't confuse with two keys. It's generally faster than other types of encryption, such as asymmetric encryption, which we'll see in a minute. It's well suited for encrypting large amounts of data, such as files or entire disk drives. It's easy to implement, but it requires secure key exchange between the sender and receiver. It can be very secure if the secret key is kept secret. secure, but it's vulnerable to attacks if the key is compromised or stolen. So what are the cons? Symmetric encryption requires a secure method for exchanging the secret key between the sender and receiver. If the key is intercepted or compromised during the exchange process, the encryption can be easily broken. Symmetric encryption is generally not suitable for situations where the parties do not share a secret key in advance, or for secure communication with multiple parties at once. Alright? So let us understand asymmetric encryption, also known as public key cryptography. Asymmetric encryption involves the use of two different keys, a public key and a private key. The public key is used to encrypt data and the private key is used to decrypt it. This means that only the owner of the private key can decrypt a message encrypted with the corresponding public key. Asymmetric encryption is used for secure communication and is generally slower and more computationally intensive than symmetric encryption. So let us understand it having a visual example. The public key is used to encrypt the messages. Okay, the private key is used to decrypt the message. Here, we have a message, for example, from Bob, and we want to send it to Alice. So in this regard, I want to encrypt the message using Alice's public key, and that message can be decrypted with her private key, meaning that only she can decrypt the message. For example, I will use Alice's public key to encrypt the message. Then it's going to be an unreadable text, which is called Ciphertext. Then Alice will decrypt that message and get it using her private key. The good thing here is that public key is open to anyone, so everyone can encrypt the message, but only Alice can decrypt the message to be able to read it. What are the pros of asymmetric encryption? It allows for secure communication without the need for exchanging a secret key in advance. Asymmetric encryption is resistant to attacks that aim to intercept and alter communication between the sender and receiver. Asymmetric encryption can be used to verify authenticity of electronic documents using digital signatures. Asymmetric encryption is widely used and supported with many applications and protocols relying on it for secure communication. It is generally slower and more computationally intensive than symmetric encryption, so in some regards you shouldn't use it. Asymmetric encryption requires the secure management of both public and private keys to maintain the security of the encryption. So what are the cons? Asymmetric encryption may not be suitable for decrypting large volumes of data due to its slower processing speed compared to symmetric encryption. Losing the private key can result in the inability to decrypt the messages, which is very important. The authenticity of a public key cannot be guaranteed, and users must verify that their public keys belong to them. Okay, that's all about symmetric and asymmetric encryption. I will see you in the next video.